Okay, today we're going to talk about solving a system with a linear and a quadratic. It's very similar to solving a system with just linear, and namely you're going to either use the elimination method or you're going to use the substitution method. These are both written in, or the top one's written in standard quadratic form, y equals ax squared plus bx plus c, and the bottom one's written in slope-intercept form, y equals mx plus b. When they're written in this form, you get a nice easy substitution right here. You're going to set them equal to each other because you can replace this y with what this y equals, which of course is 2x plus 5. If it's not in this form, it's quite easy to put the linear into y equals form. So this is like one of the most common ways to solve it, is to get it in your linear in y equals form and then plug it in where the y is on the quadratic. So let's go ahead and see what happens when we do that. So instead of y, I'm going to write 2x plus 5. So I got 2x plus 5. And the rest of this stays the same. So I got x squared plus 2x plus 4. Okay, and now I got to solve this stupid thing. And the way we're going to solve it is we're going to try to make this equal to 0, because once it's equal to 0, we can either solve by factoring or we can use the quadratic formula. And this is going to be personal preference depending on what kind of problem it is. Since I just made up these numbers, I have no idea what the answer is. My guess is we're not going to be able to factor it. We're going to have to use the quadratic formula, but we'll try to factor it and see what happens. But these are going to be your friends in order to figure out what the solutions are here. So we first need to get this equal to 0. So I need to subtract everything on the left side to get rid of it. The reason I'm picking the left-hand side is because there already is a partial number before the x squared. So I'm going to just leave it alone where it is. So we need to move the 2x. I'm going to do that by subtracting 2x. If I do it on one side, I have to do it the other. So it's going to be right here because the x's match with x's. Remember, x squared and x's are different. On the left-hand side, I got this plus 5, so we're going to subtract 5, and that matches over here with the 4, so we'll subtract 5. So let's double check. I want to get rid of a 2x, so I subtracted 2x. I did it to both sides. Good. I have a 5. I want to subtract 5 to get rid of that. I have to do it to both sides. Good. So let's see. I got 2x, take away 2x is 0. 5, take away 5 is 0. On the left-hand side, I indeed have 0. On the right-hand side, let's simplify. The x squared had no match, so it stays x squared. I got 2x take away 2x is 0. That's an interesting case. And then I have a 4 take away 5 is minus 1. Okay, so I end up with the equation x squared minus 1, and I want to see if I can factor this thing. Now, there is what's called a difference of squares. So if you remember a difference of squares, this thing is indeed factorable, and I got really lucky because it is factorable. If not, remember I'm looking for things that multiply to the last number and at the same time add to the middle number. And this trick only works when the coefficient is 1. So we're going to multiply the last number and add to the middle number. And remember, the middle number vanished. It's 0, so the middle number is 0. So how do I multiply to 1? Or negative 1? Well, I'm going to do 1 times negative 1. And 1 times negative 1 also adds to 0, so that's the answer. And if you remember difference of squares, what it ends up doing is x minus the square root of this, and then x plus the square root of this, which right here you're also seeing it is the 1 and the negative 1. Okay? And now we got to solve, and the way we solve for x is we're going to set each one of these equal to 0 separately. So either x minus 1 is equal to 0, or x plus 1 is equal to 0. And now these are one-step equations. We'll add 1 to both sides, and you get x equals 1. And then I'll subtract 1 over here. So we'll subtract 1 from both sides, and you get x equal to negative 1. So there are two solutions. X is 1, and x is negative 1. And now what we're going to do is we're going to go plug it back in here. I would recommend that you take the easier linear one, but you can plug in either one. Well, I'm going to plug it in here and see what y is. So when x is 1, I got 2 times 1 plus 5. And we're going to find out what that is. We got 2 times 1 is 2, and 2 plus 5 is 7. So one answer is when x is 1, we get y is 7. So that's one solution. Okay, and we're going to write it as a point, so we're going to write that as 1 comma 7. So when x is 1, y is 7. The other solution is when x is negative 1, so let's do it again. And we get y is equal to 2 times negative 1 plus 5. And 2 times negative 1 is obviously negative 2. And when I add 5 to that, I end up getting 3. Okay, so the other solution is when x is negative 1, y is 3. And as a point, that's going to be the point negative 1, 3. So these are our two solutions, 1, 7 and negative 1, 3. You should end up with 2 points for most cases. There are a few exceptions. You can end up a case when your line ends up being right through the vertex or otherwise tangent to it. In those cases, you'll end up with 1 point, and you might see the same answer twice over here. So that's what's going on. You only have to write it once, but you might end up seeing the same number twice. And the other case is when the line doesn't go through at all, and you end up with imaginary numbers. So if these end up being imaginary, obviously you'd be using the quadratic formula. But if you end up with imaginary, your answer is going to end up being no solution. You don't need to finish solving the quadratic formula. Just use no solution. Okay? And if you need a refresher on the quadratic formula, make sure that you go look at our quadratic formula video. But you'll just use the quadratic formula before. But you do not need to figure out what I is and figure out what your complex solutions are. You don't need to do any of that, because as soon as you know that you have a negative square root, you can stop and write no solution. And the reason for that is, we'll see in a minute when we talk about graphing, but you need to have solutions where they intersect. And if your solutions are imaginary, then there are no real solutions. And we are looking for real solutions because the intersection of a quadratic and a linear is real. Those are in the real world, so they need to have real solutions. Okay? So the only way that happens is if you end up with real solutions, either that you can factor or use the quadratic formula, you have positive square roots, or you can end up with a single case. Where this ends up being the same number twice when it's tangent. So if you have, and tangent means that it touches at only one spot. So maybe it touches like that. So there's only one solution right here. Okay. So if you have any questions, please make sure you ask. But you could have 3 cases: that, the case that we just saw where they crossed, or the case where they don't intersect at all. Okay, and this is what imaginary solutions look like. They're not intersecting at all, so just put no solution. So if you have any questions, please make sure you ask. But this is how you algebraically solve a set of linear with quadratics in a system.